Example 7. Determine the inflow or outflow to each of the reservoirs shown below. Assume Hazen-Williams coefficient 120 for all pipes. So this is the figure. So first, let's assume no flow in or out of B. So the piezometric level is level at B. So let's compare Q1 prime with Q3 prime and Q4 prime. So Q is 0.2785 C sub 1 diameter to the 2.63 slope to the 0.54. So for Q1, the slope is head loss 10, 100 minus 90 divided by length 1200. So Q1 prime 0.2785 120 times 0.75 to the 2.63, 10 over 1200 to the 0.54. So Q1 prime is 1.182 cubic meter per second. So instead of computing Q3, let's compute Q4 because it is expected that the discharge in pi 4 is higher because it is the lowermost reservoir. So if the piezometric level is at B, then the head loss would be 40, 90 minus 50. So Q4 prime is 0.2785 times 120 times 0.5 to the 2.63, 40 over 600 to the 0.54. So Q4 prime is 1.251. It is already greater than Q1 prime. Remember, we have to compare Q1 prime with Q3 prime plus Q4 prime. So Q1 prime alone is already less than Q4 prime. If we consider Q3 prime, it is much lesser than Q3 prime plus Q4 prime. Then the piezometric level, then B must also supply water to D. Now the question is, will this 3 supply to D? Because reservoir C is close to D, then if there's no flow at C, then Q1 double prime would be greater than Q1 double prime plus Q2 double prime will be surely greater than Q4 double prime, because when there's no flow in or out at B, remember that Q1 prime is close to Q4 prime, although it's less. So we are sure that the piezometric level is between B and C. So the discharge formula would be Q1 plus Q2 equals Q3 plus Q4. So that's the discharge formula. So let's denote HF1 equals H. HF2 equals H minus 10. Because 100 minus 90 is 10. HF3 is 40 minus H. 100 minus 60 is 40, so 40 minus H. HF4 is 50 minus H because 100 minus 50 is 50, and minus H, so that's HF4. Then the equation Q1, 0.2785, C sub 1, 120, diameter 0.75 to the 2.63, slope H over 1200 to the 0.54. We will not cancel 0.2785, 120, so that the whole of this represents Q1. Plus Q2, 0.2785 120 times 0.65 to the 2.63 times quantity H minus 10 over 1000 to the 0.54 equals Q3 0.2785 times 120 times 0.6 to the 2.63 times quantity 40 minus H over 600 to the 0.54 plus Q4 0.2785 times 120 times 0.5 to the 2.63, then quantity 50 minus H over 600 to the 0.54. Simplifying all these terms, 0.3409 H to the 0.54 plus 0.2582 quantity H minus 10 to the 0.54 equals 0.2756 quantity 40 minus H to the 0.54 plus 0.1706 quantity 50 minus H to the 0.54. The expected value of H is between 10 and 40. 10 and 40. So try any values between 10 and 40, then solve for this equation by trial and error. Then H is 18.992 meters. Then we can now solve Q1, 0.3409 times 18.992 to the 0.54. So Q1 is 1.671 cubic meters per second, and it is an outflow. Q2 is 0.2582, quantity 18.992 minus 10 to the 0.54. So Q2 is 0.8454 cubic meter per second, and it is also an outflow. Q3 is 0.2756, quantity 40 minus 18.992 to the 0.54. 1.427, and it is an inflow. As well as Q4, it is an inflow, 0.1706, quantity 50 minus 18.992 to the 0.54. So Q4 is 1.090 cubic meter per second. It is also an inflow.